Hello everyone! In this video, I'm going to tell you about my long journey of learning all galvanoplasty tricks, namely copper plating and nickel plating. Besides, I'm going to tell you about how to prevent almost any object from aging and make it practically eternal, protecting it with a layer of metal and making a beautiful decoration from it. My first encounter with galvanoplasty was more than a year ago, when I decided to coat a few metal objects in copper and also to make them shiny with the help of special electrolyte additives. Among all the easy-to-get additives, which are also known as brighteners, I had only black treacle of molasses. This is a black product resulting from refining sugar. It contains minerals and vitamins and also coloring agents, which white sugar is purified from before it goes on scale. I mixed 200 ml of water, 40 grams of copper sulfate and 5 ml of concentrated sulfuric acid for preparing acid copper plating solution. Such an electrolyte is common for simple copper plating. However, usually such coating isn't smooth and shiny. To improve brightness and smoothness of the items, I added 2 more grams of black treacle, which is supposed to make the copper layer smoother and brighter. I ran a test in which I used a copper plate as an anode and tried to coat an old razor with copper. I set current to 2 amperes per square decimeter. The razor turned out to be made of steel, which is why the copper layer immediately came off in acidic electrolyte. Yes, the first attempt failed, but I used a stainless steel hand watch case. Back to the second test. Half an hour later, it was covered in a durable layer of copper, which wasn't shiny, but was even and didn't come off. The same happened to other metal objects. Coins, a key and other metal objects were covered in a beautiful layer of copper, because all of them were either made of brass or nickel. This layer could have easily been polished with an abrasive, just like I polished this coin. However, copper coating isn't particularly very durable, and when exposed to air, such copper-plated objects quickly fade, especially when they are frequently used. That is why I decided to add an additional layer of nickel to this polished coin. The nickel electrolyte I made was similar to the copper electrolyte. The only difference was that I used nickel sulfate instead of copper sulfate, but in about 5 minutes the nickel layer started coming off the coin and it wasn't that shiny. That I then decided that this experiment was taking too much time and decided to postpone it until the moment I have more time for that. So now, a year later, I think it is time to continue the experiment. I have learned so much about electrolytes over the past year and purchased various brighteners, and now I am ready to make electroplating masterpieces. I decided to coat real leaves rather than some boring metal objects. I also decided to do that because it is quite challenging to perform copper or nickel shiny plating of iron, aluminum or zinc objects in acidic electrolyte because of these metals' electric potentials. So, let us start with leaves. After collecting leaves, I dried them for a couple of days in order to see which ones of them did not shrink out of shape when dried. 2 days later, we can clearly see that oak and aspen leaves keep their shapes the best. Maple leaves also showed good result as well, as a 2 a twig, so I decided to use them for my experiments. The first step in creation of such DIY decorations is coating them with a layer of current-conducting chemical. Graphite fits here perfectly well. You can buy special graphite spray in shops, which covers objects with an even layer and is very handy to use. We need to coat leaves of 3 layers of graphite, and each layer has to be dried separately in order for the current-conducting layer to be as smooth as possible, to cover the entire surface area of the leaf. Besides leaves, I also used a pen plastic cap. Its shape is quite interesting looking and is perfectly fit for copper plating and that nickel plating. When the leaves dried, I decided to use an oak leaf for the first test, and coat it with copper in a regular electrolyte, consisting only of copper sulfate and sulfuric acid. However, as you can see yourselves from this time-lapse, spreading of copper sediment is not done evenly, and the surface doesn't look smooth. It took about 12 hours to coat this leaf in copper with 400 mA current. Besides, not all the surface area was covered copper. When we look at the footage shot in the macro mode, we can see crystals of copper. Their size is quite large, which is why the entire surface looks like sandpaper. That is why it doesn't look very attracting. Because of the lack of additives in the solution, crystals of copper are too big. This electrolyte needs to be improved. Besides, my container for copper plating doesn't seem to be fitting for this. So I decided to put an end to that. To improve the process, I decided to assemble such a tub with two large copper plates, working as cathodes, in order not to experience deficit of copper. When running my first experiment, I decided to reinvent the wheel, instead of following the instructions. As a result, I decided to combine my previous experience and knowledge I have obtained from the internet. I used 200 grams of copper sulfate, 20 milliliters of concentrated sulfuric acid, 8 grams of my favorite black treacle, and 30 milliliters of alcohol as a surfactant, in order for the layer to be even for 1 liter of solution. During the first experiment, the power of current was set to 3 amperes per square decimeter, which means that I calculated an approximate surface area of each leaf in square decimeters and multiplied it by 3. I set current to 600 milliamperes for the first aspen leaf. By the way, at the beginning stages of copper plating, it is better to use weak current and then gradually increase it. This time it took about 10 hours for the leaf to be fully covered in copper, although the layer turned out to be a bit too thick. After doing copper plating, I noticed that the copper layer wasn't as smooth as I expected. That is why the next thing that needs to be done after regular copper plating is electropolishing, for which I need to prepare another solution in a beaker. I made a base from regular acidic copper electrolyte and sulfuric acid for it. After that, I added 1/100th of a gram of thiourea and 1/10th of a gram of disulfonaphthonic acid. After that, I dipped a copper-plated aspen leaf in such a solution and applied current, measuring about 4 amperes per square decimeter. Such a process allows to produce a glassy layer of copper without using abrasive. Adding thiourea and disulfonaphthonic acid helps reduce the size of copper crystals so much that their surface becomes shiny like glass. All of this is just a theory. In practice, without stirring the solution, my leaf was taking too long to cover in shiny layer of copper. That is why I decided to stir it and increase current. Because of thiourea in the solution, there formed sediment, most probably consisting of 1-valent copper compounds, which is why current had to be increased by more than 3 times to ensure an even spread. However, this process was too demanding, and in about 3 hours of toiling away, I got this ugly thing. It is shiny only on the bottom. We can compare it to the previous leaf samples covered with copper in a regular solution. As we can see, that brighters helped just a little bit. While I was trying to make this leaf shiny, I noticed that yet another oak leaf in the big tub covered in copper. But this time, I'd like to produce a shiny layer of copper in yet another way. I looked it up in one Soviet patient from the 70s. I added 14 grams of copper sulfate and this time 20 milliliters of sulfuric acid, 1/100th of a gram of thiourea and drop of unitol in 2 milliliters of water. This substance is sold in Russian pharmacies as detox medicine in the form of 2,3-dimercapto-1 propanesulfuric acid solution, which is an organic sulfur-containing compound. It is much easier to get it than disulfonaphthalene acid. So, let us try to make this copper leaf shiny again. The new solution exceeded all my expectations. The oak leaf wasn't just more pale, it really covered in a glassy layer of copper. Let's consider the mechanism of this reaction. Just like disulfonaphthalene acid, 2,3-dimercapto-1-propanesulfuric acid, which is contained in unitol, has links between carbon and oxidized sulfur, which increases cathodic polarization and also improves effectiveness of copper spreading, and also forming crystals do not grow too big in size. These additives are something like reaction inhibitors or retarders of copper crystals growth on the surface of leaves. In this case, TOURE is a surfactant, which also improves spreading of copper. This process lasts about 2 hours. Now, when the process of copper plating is over, I would like to show you the beautiful result. When exposed to the air, however, this leaf quickly started oxidizing because of a large surface area and also because copper crystals in this layer are too small. That is why this shiny copper layer immediately needs to be covered in a protective layer of nickel in order for the copper not to fade and oxidize. Besides, the copper layer is quite fragile, which is why this copper leaf can easily break. To remove the copper oxide layer from the leaf and prepare it for nickel plating, I put it in a 20% sulfuric acid solution. While oxides were being removed from the copper-plated leaf, I decided to prepare electrolyte for shiny nickel plating from what I had available to me. I am pouring 50 grams of nickel sulfate, 5 grams of boric acid, and 2 grams of sodium chloride, which is regular table salt. After that, I am pouring about 250 milliliters of water and also brighteners. 1/100 of a gram of TOURE and 1/10 of a gram of disulfonaphthalene acid. I used a nickel strip as an anode, which I was sent by a Chinese manufacturer. I sliced the nickel strip into a few smaller strips and attached them to the beaker as anodes. After that, the copper leaf is ready to be plated with nickel. I set current to 800 milliamperes. It was a rather random choice. To my surprise, nickel stuck to the copper in an even layer and didn't come off. The whole process took about 20 minutes. We can check the nickel layer by the item's color. If its color is yellowish, it means that there is not enough nickel and plating has to be continued. Nowadays, this of nickel plating with copper is used very widely. For instance, this method is employed to plate some displays, neodymium magnets, tapes, coils, and lots of other items. When the item is nickel plated, it looks pretty beautiful and interesting and resembles silver. By the way, in my opinion, there is no need to silver plate such a leaf, because in time silver oxidizes and fades in the air. The only thing I do not like about this leaf is that the copper layer is too thick. That is why I decided to change the electrolyte in the big tub to a well-proven one and not to use black treacle. I made a new improved electrolyte from 100 grams of copper sulfate dissolved in 500 milliliters of water. Then I added 70 milliliters of concentrated sulfuric acid and 3 milliliters of ethanol as a surfactant to this solution, to improve the surface with a little bit of gelatin dissolving it. When I carried out further copper plating of aspen leaves, the copper layer were much thinner, and it took less time for leaves to be plated. That is why the latter electrolyte is better than the one with black treacle I used. After copper plating, I decided to polish the leaf in another solution with anitol. However, the solutions began to grow muddy because of containing TOURE. That is why I had to increase current by 2 times. It took me 3 hours to polish it. Such a method of electropolishing is much better than mechanical polishing because less copper is needed, and nickel will stick better to the copper layer because of a larger surface area. It is better to store such leaves in 20% sulfuric acid after electropolishing in order for them not to oxidize in the air and be better prepared for nickel plating. When I nickel plated it later on, it became a nearly perfect eternal leaf, which can easily be used as a gift for a beloved person. Why nearly perfect? Because in the beginning current wasn't strong enough, which is why there formed such bumps on the leaf. That is why you need to keep constant watch on the solution during brightening, and as soon as the solution starts turbiding, immediately increase current by 2 times and observe the result. Besides aspen leaves, I also copper plated, brightened and nickel plated a tuya twig. So, if you liked this video, please give it a thumbs up and also subscribe to my channel to see many more new and interesting